Assalamu alaikum everyone, my name is Bexzod Djumabaev from Tashkent State University of Economics. In this video I want to show you how to make a research using Stata software. So first of all we should enter to the Google and search for World Bank Open Data Source, and so we should select the country, and here we can see the countries, and in my occasion it is South Korea, and you should select one country that you want to make research for. So this is the South Korea's profile, and we should download the Excel format of the data, and that's I already downloaded it. And first of all we click to the data and select the country name and our variables. So, and the important things that I want to mention is when you have copied, for example, you have copied this country name, we should open the new folder, and as you can paste it, you should select the force you have transposed it and paste it in this format. So you may have some problems with the years. That's because of the fact that Excel read the years, convert the year. We should convert the years into the numbers, not as the information, because the Excel thinks that it is the information, not data, not the numbers. So I have already prepared. So this is the my data. So we go to this data, and we should click on the file, import, Excel spreadsheet, and browse. And this is our prepared Excel format. We should import first row as a variable name, because that's not the numbers or data, it is variables. So okay, here we can see our variables. So the next thing that we should do is create a log file. So how we will do that is we should click to the force button here and create a log file, give a name, and select the second log type of file and create it. So the next thing that we should do is browse. So here we can see our data. Browse command gives us information about whether data, time series, descriptor, numerical, and so on. So in my case it is time series, secondary source, numerical, continuous. So we close the browse, and here I already prepared comments that I will use in my research. So here is the comments. So the next thing, as you can see, that we should install the document, world document. So this gives us that the information that we will get from this data will be converted into world file. So that will be easy for us to convert it. So the next thing that we should do is to summarize. So here we can see years, variables, years, GDP, ICT, industry, and taxes, observation number, arithmetic mean, standard deviation, minimum value, and the maximum value. So as we can see that some of our variables, for example ICT and taxes, the observation number are less than 63. That's because of South Korea didn't provide information for World Bank. That's why there is some misses. So the next thing that we should do is tset years. What it will give us. So the tset command in Stata is used to set the time variable when working with time series data. Time series data involves observation taken at different points in time, and the tset command helps Stata understand the time structure of your data. So this I have converted my data to tset to time series. So the next thing that we should do is draw the TC line. So here it is, and we should copy it and paste it into our Word document. Here I've prepared already. So we paste it into a result section. Here it is. I forgot to mention that we should also paste the sum of our result sum, which is here. We also click to the my file document and open. So state automatically open to us the Word document. So here we copy it and paste it into our document. Here it is. So the next thing that we do is draw the scatter. So here it is. It explains us whether the relationship between two variables, in my occasion it is GDP and ICT, is positive or negative. Here we can see the positive relationship between these two variables. So we also copy it and paste into our Word document. Here it is. And the next thing we will move into next the next thing is to draw the graph box. So what is graph box? I'll explain you. So this is the outliers. Here it is the 0 and around 1.7. So this is the outliers of the graph box. Explains the 75% of all data. So here we can see that our data lies in 1 and around 1.1 in here. In this area our data lies 75% of our data lies in this triangle. So this is the median of our data. So in this occasion it is GDP. So we also copy it and paste into our Word file. So the next thing is to draw a histogram. So what is histogram? Histogram is the it's also the graph which is the test that explains it is a normality test that the histogram should draw a bell shape. Here we can see the bell shape. So from that we can say that our data is normally distributed. If the graph is not bell shaped, so our data is not well distributed, that may cause some problems. So we also copy that and paste into our research file. So now let's move on to Pearson pairwise correlation matrix test. So I should close. I want to remind you that we should close the my file document in order to open it, because Stata will not open it again. That's why we should close it in order to open it again. That's why we select the SDoc and try to open it. So here we can see the Pearson pairwise correlation matrix test. So it explains us the relationship between variables. The relationship between GDP and GDP, it calls single-wise correlation, and the relationship between GDP and other variables like ICT, industrial taxes, and transport services are pairwise correlation. So from this table, we can understand that the relationship between GDP and ICT is 70%, and it is statistically significant. So we also copy it. We open the my file document and copy it and paste it into our document. So here we can see it, and now let's move on. So the next thing that we should do is regression. So in Stata, the regression command is used to run linear regression models. Linear regression is a statistical method used to model the relationship between a dependent variable and one or more independent variables by fitting a linear equation to the observed data. So here we can see ANOVA table, model parameters, and result table. So so what can we understand from that? So in ANOVA table, we can see that models, residual, and total. So so the first thing is this represent the variability in the data that is due to differences between the groups means. It is often referred to as a treatment or factor effect. The second is residual or error. This represents the variability within each group, which is not explained by the group differences. It includes random variability and measurement error. So as for DF, it is degree of freedom. The degree of freedom associated with the first is the first degree of freedom associated with the between group variation. It is number of groups minus 1. So because of the why, if you can ask why it is not 5, that's because of GDP is a dependent variable. That's why it is 4. Here we can see that 4 independent variables. That's why it is 4. So the second is 41. So this is the degree of freedom. The second is the degree of freedom associated with the within groups variation. It is the total number of observation minus the total number of groups. So it is 41. So what is SSS? It means sum of squares. The first number explains the sum of square differences between each group mean and the overall mean multiplied by the number of observation in each group. The second the second one is the sum of square differences between each individual score and its group mean. So and the last one is MS, or it calls mean square. The first is the sum of squares between the divided by the degrees of freedom between, and the second one the sum of squares within divided by the degrees of freedom within. So now let's move on to the model parameters. Here we can see it. This is the number of observations, 46, and F ratio. We can see F ratio here, and you can ask why it is 4 and 41. So why 4? 4 because of we have 4 independent variables and 1 dependent. Why 41? I can say that 41 we can get from, if we sum the 41 plus 4, we can get 45. So one year we can we take as a dependent year. So from that we can see the compare this year from with other years. So the and this next one is p-value. Here we can see that p-value is less than 0.05 and it is statistically significant. The p-value, the probability associated with the f ratio, the p-value is below a predetermined significance level, commonly is 0.05. The null hypothesis is rejected, suggesting that there are significant differences between group means. So now let's move to the R squared. What is R squared? The R squared coefficient of determination is a statistical measure that represents the proportion of the variance in the dependent variable that is explained by the independent variables in a regression model. In other words, it indicates the goodness of fit of the model, how well the model predicts the variation in the dependent variable. Adjusted R squared, we can use that when the number of observation is less than 31. So let's move to the let's move to the result table. So from here we can see coefficient table. Here it is, coefficient table, and the standard error, t value, and the p values. So let's start with coefficient. The coefficient column displays the estimated coefficient for each independent variable in the regression equation. These coefficients represent the expected change in the dependent variable for a 1 unit change in the corresponding independent variable, holding other variables constant. So standard error column provides the standard error associated with the estimated coefficients. Standard errors measure the precision of the coefficient estimators. T-statistics. What is T-statistics? T-statistics column shows the T-statistic for each coefficient. The T-statistic is calculated by dividing the coefficient by its standard error. So if we divide 9 into 1.91, we can get 4.71. So p-value. P-value displays the it indicates the probability of observing a t-statistic as extreme as the one computed if the true population value of coefficient is 0. A low p-value, typically below than 0.05, suggests that the coefficient is statistically significant. So the next thing that we should do is Sharipov test. So the Sharipov test is a statistical test used to assess whether a sample comes from a normally distributed population. It tests the null hypothesis that a sample is drawn from a normally distributed population. The test is particularly sensitive to deviations from normality in the tails of the distribution. So we should reject the H0 hypothesis and move to HA hypothesis. The null, or it's sometimes called the null hypothesis, is H0 hypothesis. The null hypothesis of Sharipov test is that the population from which the sample is drawn is normally distributed. The alternative hypothesis, which is HA hypothesis, is that the population is not normally distributed. So we can say that H0 hypothesis says that the variables are independent, and the HA hypothesis says that variables are independent. So we should reject the H0 and move to HA. So the next thing is alpha comment. So alpha comment explains the reliability of our model. So my model is reliability of my model is around 83%. So let's move on. We should comment t-set years again. T-set years, here we go, and then install the JB. Thing that we should do is stat-Watson command. So stat-Watson, this command is used to calculate the Durbin-Watson statistic after estimating a regression model. The Durbin-Watson statistic is a test for the presence of autocorrelation in the residuals of a regression model. It has a value between 0 and 4. A value around 2 suggests that there is no significant autocorrelation in the residuals. A value significantly below 2 may indicate positive autocorrelation. Residuals are, or in other words, residuals are correlated positively with their neighboring residuals, while values significantly above 2 may indicate negative autocorrelation. Interpreting the Durbin-Watson statistic helps assess the assumption of independence of residuals in a regression model. Autocorrelation in the residuals can affect the reliability of hypothesis test and confidence intervals, so addressing it is important for valid statistical inference. So the next thing is stat-VIF. So VIF, or with other words, it means variance inflation factor. VIF measures the extent to which the variance of an estimated regression coefficient increases if the variable is correlated with other independent variables in the model. A high VIF indicates that a variable is highly correlated with other predictors, suggesting potential multicollinearity issues. So let's move on. So the next thing is predicting I hat. So if we browse, here we can see I hat. In Stata, the predict I hat command generates predicted values based on a regression model. The variable I hat represents the predicted values of the dependent variable from the specified regression equation. It helps you assess how well your model fits the data and can be used for various analyses such as evaluating residuals or comparing predicted and actual values. So the next thing is that we should do is a stat head test. So what it will give us, this command is used to perform a heteroscedasticity test after estimating a regression model. Heteroscedasticity test refers to the situation where variance of errors is not constant across all levels of independent variables. The stat head test command assesses whether there is evidence of heteroscedasticity in the residuals of the regression model. The null hypothesis of the test is that the errors are homoscedastic, or in other words, constant variance, and the rejection of this null hypothesis suggests that the presence of heteroscedasticity. The test provides valuable information for understanding the reliability of the estimated regression coefficients and for deciding whether adjustments to the model are needed.